Hi, this is Mr. Max. So today I'm doing graphs of power functions. All right. So the type of graphs that we are dealing here has to do with graphs the type of A raised ax to the power n, where the a is a rational number and also the n is a rational number. These are called power functions. So I'm going to look at when n is -2, -1, 0, 1, 2, and 3. Right, so let me bring in when n is equal to 0, for example. So let's take any particular graph. So let me take, I have 2 here, y equals to 2 for my value of a, x is equal to, or x raised to the power of 0. So what you're going to have, you realize that it's going to be a straight line, which is basically just y equals to 2, because that x raised to the power of 0 is 1 and 2 times 1 is 2. So if I make x or y equals to -3x to the power of 0, so that x to the power of 0 is 1, and then you only have a linear or constant function here, so that is going to be a particular graph like y equals to some constant, some number, okay, because that x to the power of 0 is nothing but 1. So if you have y equals to -3, y equals to 2, whatever that is, it's just going to be a constant function, okay? Another type is when you have that n, or that power that equals to 1. So if I bring in 2 that I have drawn on one grid here, so here I've drawn the graph of y equals to 2, x raised to the power of 1. So this is nothing but the graph of y equals to 2x, which are linear functions, all right? And also if you decide -3x, obviously because it's negative, the graph is going to go in a downhill direction, all right? So these ones are called linear functions, but they all belong to the family of power functions. Right, what about if we have n equals to 2? Well, this one is quite familiar. It's a quadratic function. Right, so I have here the one in black, y equals to 2x squared. And here I've got when the value of that number, the a in front of the x squared is very small, the graph will open up a bit. Okay, so this is basically the graph of y equals to -3, -0.3 x squared. These are all quadratic functions. The other type is when you have cubic functions. So a cubic function is typically when you have that power there as a cube. All right, you have a typical graph like this. So here I've just sketched the graph of y equals to 2x cubed. So this is also a power function, but it is known as a cubic function. All right, then we have done the reciprocal functions, which you know, basically they are parabolas here. So it has got a reflection, all right, and also that value of x. So this graph is nothing but the graph can also be written, for example, as y equals to, then here I have got 2 raised to the power of x. So this is basically exactly the same as that, okay? And also if you refer to previous videos of mine, you would have seen that I have done this particular type of graphs. The last one, which also belongs to power function, is when that n is -2. Well, if you have to draw one, like I've done, y equals to 2x raised to the -2 power, you're going to have a particular graph that looks like this with its reflection on the y-axis. Now, one thing you should know is that this graph also does not cut the y-axis, all right? Because if this graph, basically, if I rewrite it, it's y equals to, then it's 2, and then the x square is underneath, all right? And you know that x cannot equal to 0, so that is why that particular graph there will basically have that sort of asymptote with respect to the y-axis. X cannot equal to 0 because this graph here, this line, the y-axis is the line x equals to 0. So there are no readings, so these graphs of yours will not intersect with the y-axis. Okay, so these are just in a nutshell the type of graphs that we are dealing with when we are talking about power functions. Right, so I'm going to do the sum of power functions. Basically what I'm saying is, for example, if I take a graph of y equals to 4 over x squared, and I take a graph of y equals to x, and we sort of get them together, all right, we add them. So I'm going to be left then with y equals to 4 over x squared plus x. So the best way to do this particular function, because it's a new function, will be if you use the construct a table method, all right. When you construct a table and then you plot on the graph, you should be able to see how this particular functions will look, or this function. So I also see a denominator for my x, and I know that the denominator, the x, also can't equal to 0, which tells me something that this particular graph, if I'm going to draw it, it will also form an asymptote with the y-axis. Right, so let us bring in a table of value. Right, so we have got a table here. So I started from -2 and some values in between, and then -1. But here you can see there's nothing here because x can never equal to 0. Then I have 1, 1.5 up to 4. So I left out when x is 3. So the first question is you're supposed then to find to one decimal place what that particular value will be. So it's nothing but 3.4. So you punch basically that for x into the function. Okay, so you have got 3.4 there. So remember, basically you have to take that and make sure I put brackets here, because sometimes if this is negative or here, students tend to make mistakes. So what I am saying here is we are supposed then to draw this graph, and we are supposed to use a scale of 2 centimeters to represent 1 unit on both the axes. All right, so before I draw this graph, let me bring my table back, a completed table. So this is what I expect. So I know that the maximum value, the highest value of y, looking at this, is 5.5. So my graph can go all the way up to 6. And I know that I have to go -2 up to 4 on the x-axis, all right? And then the lowest part is -1 here. So I can draw something like this, all right? I should be fine. My graph should be able to fit in this particular region. So you should have an expectation before you just start with taking your graph paper and start with your axis, because you will not know how high up or how low you should go. Obviously, the x values are given to you, all right? Now, I expect something like this, all right? And I also know that this particular graph, if I'm going to draw it, is not going to intersect with the y-axis, all right, because of that fraction there. So let me bring my graph paper. So here I've got my graph paper with my scale, and I have labeled my x's. All right, so let me bring in my table. Right, so I am going to plot all of these points on my graph paper. So I'm going to start with the point -2, -1. Okay, and then -1.5, 0.3. So you must make sure that you find that small particular square there. And -1, 2, I get an output of 1.6, and -1 is 3, is all the way up there, and then -0.8, which is close to -1, I get 5.5. So that does it for that side. So when I come to 1.5, 1.5, 3.3, 2, 3, 4, or 3, 3.4, the one that I have calculated, and 4.3. All right, so when you actually now draw them, after you have drawn your graph, you also label your particular graph. So this is the graph of y equals to 4 over x squared plus x. So we're going to go ahead and answer some more questions pertaining to this. So let me bring my graph back again. And then the first question that comes is you're supposed to use your graph to solve, all right, not algebraically. So we solve this when 4 over x squared plus x is equal to 0. So this 0 tells me is this particular line, which is the x-axis, because this line here is where y is equal to 0. Okay, so the x-axis is also known, and this is very important, the x-axis is also known for y equals to 0. That is the x-axis for you. So when we are told that we are supposed to find where the graph is equal to 0, it is where does my graph, and it only cuts it at one place. It only cuts the x-axis at one place, because 0, y equals to 0 is here. So you then give that particular value. Mine here is about -1.6. All right, so we will definitely also give you an answer that is probably very close to that, maybe off by 1 decimal place, something like -1.5 or -1.7. Anything in that range, we are going to give you an answer. Right, then there's a C part to this particular question here, and the C part is similar like the first, but the only thing here that you are now told is you're supposed to solve the equation when y equals to 0. So basically now I have got 4 here. In the previous one I had a 0, so 4 here. So that tells me I should draw the line y equals to 4. Okay, so once we have drawn the line, you see that the line cuts the function at 3 places, and we are saying solve for x, then we have to find all the 3 values of x. So my first one is about negative 0.9, okay, and the second one here will be about 1.2, okay, and then the third place where they intersect is about 3.7. So anything more or less in that vicinity is what we are looking for. You're supposed to use your graph, remember that. Right, again, I'm going to do a second question. It's very similar to the first, but the function is a bit different. So you have your function x over 2 minus 2 over x. All right, so again, I have got an x there and part of a denominator, so I know that this graph also will break somewhere. It's going to be discontinuing. All right, so it will also cut the y-axis. It will not be possible. All right, and then I know how I should go with my values of x on one side and on the other side up all the way up to 4. So x cannot equal to 0, so there's not going to be a value when you include 0 in there. So here they have a table that they have given me, or that they have asked me to complete the missing values there. So I've got p and q and r that are missing. So it's very straightforward. To find p, you plug in -1 into your function everywhere where you have an x there. All right, so I get 1.5, and when I plug in -0.5 into my function, I get 3.75. It's very important that you get these points correct, and for r, when I plug in 1, I will get -1.5. So this will allow me now to complete my table, and I've got a lot of points. So the more points you have, the smoother your curve. And remember, when you draw this curve, you are not supposed to use a ruler. You draw it with a free hand. Okay, so this is my table. Now it's complete, so I can go to the next step. So the next step says, on a sheet of graph paper using a scale of 2 centimeters to represent 1 unit on each of the axes, we are supposed to draw this graph now. So let me bring my table back, my completed table as it's there. So from this table, I can learn a few things, that the maximum value, the highest value of y is 3.75. So my graph can go all the way up to 4. All right, and the minimum value here, it's -3.75. So it can also then go to -4. And then if you look at the x, your domain there, the domain has to be from -4 up to 4. So I will draw something like that, and I expect to deal in that particular area, and they should all fit in there, and make sure that you follow the steps that you have. All right, so in a nutshell, I'm looking at something like that. Okay, so the graph will definitely cut the x-axis, all right, but it will not intersect, it will not cut the y-axis because of that denominator there. All right, so let us see if I bring up my graph paper and I plot this table. Right, so this is my graph paper. So I'm going to divide the table into 2 parts. One part will be here on the left because it breaks with 0, remember. So I'm going to plot these points and see how it behaves now. So -4, you get -1.5. -3 is about -0.8. Maybe you can go up to the decimal place, okay? -2, 0, -1.5, -6 somehow, -1, which is also here at 1.5, and -0.5 all the way up to, let's say, 3.8. Okay, so that does it then for that part. So let me bring in the other part here, all right, of the table. So when it's 0.5, I get a -3.8, very close somewhere down there. When it's 1, I get -1.5, and I have plotted it. When it's 1.5, I get up close to -0.6. So these two graphs will be reflections of each other. So when it's 4, it's about 1.5. All right, so I'm going to draw then the graph. You have to use your free hand when you draw it, and then you label your graph like that. Okay. So let me bring my graph back because there's 2 more questions that are coming here. So they're saying you're supposed to use your graph when you solve this equation of a whole function here equals to 1. So that equals to 1 tells me I must draw the line y equals to 1. And where the two graphs, the functions, where they are intersecting, this is going to be the solution to this equation. You're not using algebra, but you're using your graph. All right, so here's one place where they intersect. I get about negative 1.2. Another place where they intersect, I get about 3.2. All right, so anything in that particular region will be accepted. So let me bring my graph once more back, because there is one more question, actually 2 or 3 more questions. They are saying we're supposed to draw this line here. Now, let me, for those of you who do not know how to draw the line y equals to negative x. All right, so if I bring up a table and I take values of x to be negative 4 and 4, and I punch it in here, when x is negative 4, I get a positive output. All right, which means I plot it up all the way there. When x is 4, I get negative 4, which means I plug it all the way down here. So you only need 2 points, okay, to draw a straight line. And that is exactly what I have done there, okay? So only 2 points that you need to draw a straight line. And I took the extremes so that my graph can go right through, all right? Because I might be asked questions on where they intersect and stuff like that. So the second part of D, Roman 2, says you're supposed to use your graphs to solve where my function meets the line. So again, it's the x values that you have to write. So one will be negative 1.1, and the other part will be about 1.1. All right, so these are the two solutions for this particular question. You use your graph. Very important that you understand that. Right, there is a E part that are saying write down the equation of the line which passes through the origin, all right, and it does not intersect with the graph of x over 2 minus 2 over x, all right. So we are going to find the equation of the line which does not intersect, So one of the things that you can see is obviously the graph which passes through the origin is the graph of y equals to x. Now I can't use y equals to negative x, because the moment I use negative x here, all right, it's obviously going to affect my graph. It's going to cut my graph at 2 places. So the gradient has to be positive, all right, but the gradient there also has to be a certain value, all right. That gradient has to be bigger than or equal to a half, because you will see, I'll take one example where I make the gradient to be less than a half, so you can see exactly what we mean by that. All right, so if I was to take a graph like when the gradient is a half, and I bring in a table and I complete my table, so for x is negative 4, what do I get? When x is 4, what do I get? So if I plug these particular points and I draw that graph of y equals to negative a half x, again negative a half x, you will see that it will not intersect with my graph. All right, and anything then bigger than that, okay, bigger than a half, all right. So in the next slide, I will show you what happens when we pick, say for example, a value that is less than a half. Let's say we do 1/4. So if I choose like 1 over 4, and let me bring in a table again. So when my k is 1 over 4, which is considerably less than half, okay, and you plug in negative 4, you get negative 1, all right, you see that point somewhere here. When you plug in 4 there, you get 1, which is somewhere here. You can already see that the moment you start drawing a line there, it will start intersecting with the graph, okay? And therefore, it will not work. So our particular graph should be y equals to x, or some number in front of the x besides 1 that is obviously greater than a half. So this brings me to the end of this particular presentation. Now, I know that somehow I also went a bit fast. I suggest that you pause the video a bit and then you check with your particular solutions and see and compare where you did not understand certain things. Don't forget to subscribe to my channel and click the notification bell